In this problem, we're going to look at the strain in an axial loaded bar. And we have an initial length of 2.6 meters and a change in length of zero point 0.8 millimeters. And our goal is to calculate the strain in the x direction. And we're going to use units of percentage, if you can even call percentage a units, because this is going to be dimensionless. So we have our bar with some length, and it extends a little bit to have a delta L. So one thing to note, we've been given the change of length of zero point 0.8 millimeters, and I wasn't very specific in terms of is this positive or negative delta L, but we're going to go ahead and say that it is positive to the right, and so it's expanding. And if you were given, say, a final length and an initial length, it would be that final length minus the initial length to come up with a delta L. So going to the math, we have epsilon x is equal to delta L over L, and that's going to be 0.8 millimeters over 2.6 meters. And we want to go ahead and make sure that we are in the appropriate units. Well, to do that, let's make sure that we divide meters by meters. So we're going to convert these millimeters to meters, and then so this quantity here. And then we'll go further and just multiply by 100. I didn't write it out, but it would be 0.00031, but then we multiply by 100, so we get 0.031%. And that's how we go about doing this problem. We can once again, if we like, go to a web browser. Let's see. Okay, yeah. And if I put the, oops, I won't do it there because I will go to DuckDuckGo. If I go 0.8 millimeters divided by 2.6 meters, what are we going to get? We get this quantity. I don't know. I haven't done it in percent. Let's see. Let's see what happens. Yep, and it even will convert into percent if you like. And going into Python, we can quickly run this calculation. And at this point, you probably don't need to watch the video if you're familiar with how to do these things, but if not, go ahead. And so we'll do the import numpy as np, and we hit Control Enter. We do the code. We've got a delta L equal to 0.8 millimeters. And for this, I would go ahead and multiply by 1e to the minus 3. And then that means that we're in meters, just to keep it simpler. And L is equal to 2.6 meters. So I'll put that just like that. Again, that's just commented out. So we're going to have strain in the x direction, which will be the delta L divided by the L. And this will have no units, so we can maybe just leave it like that, or we can say unitless. And we can print the result that the strain in the x direction is going to be equal to np.round, and we'll do strain x. And this is unitless, but since we wanted it in terms of percentage, we can do multiply by 100. Okay, and then we have an idea that we probably want a few more decimal places than normal, so we'll do 3 decimal places. And then we can say that is going to be a percentage, like that. Okay, and so we apply, and we get 0.031%. Thank you. Have a good one.